My dear Powers and Churchill. Okay, from today is okay. Why didn't you attend for previous classes? Which is important? Which is important? Your math class or going out? Which is important for you? Decide yourself. You decide yourself, my dear Powers and Churchill. It is up to you. If you are not attending the math classes, you can't understand. You can't understand the concepts well. Are you watching the videos, my dear Powers and Churchill, regularly? At least, are you watching the videos? Powers and Churchill? Yes, okay. Then it's okay. Somewhat better. Somewhat better. Okay. Have you memorized the formula? Have you memorized the properties of inverse trigonometric functions? My dear children?
Yes, sir.
Yes. Just 2 minutes I will ask you. All of you listen carefully. If you don't know, nothing to worry. At least learn the formula now itself, at least. Who will know the answer? Just to raise your hands and let the others listen. Sine inverse of minus x. Others just to concentrate. Listen carefully, my dear children. Sine inverse of minus x is equal to. Okay, my dear Grayson, tell me.
So minus sine inverse x.
Yes, cos inverse of minus x is equal to. Okay, my dear Preetika. Okay, first Preetika raised her hand. Tell me cos inverse of minus x is equal to. Very good, Preetika. All of you listen carefully, my dear children. Tan inverse of minus x is equal to. Yes, my dear Joseph. Tell me.
Sir, minus tan inverse x.
Very good. Cot inverse of minus x is equal to. Okay, my dear Preetika. Tell me cot inverse of minus x. Very good. Are you listening, my dear children? At least now, listen these formula. Then you can learn at least some little bit. Secant inverse of minus x is equal to. Okay, my dear Kiran Raj. Kiran Raj.
Sir, pi minus secant inverse x, sir.
Very good. Last, cosecant inverse of minus x is equal to. Very good, Kevin Paul. Tell me.
Minus cosecant inverse x.
Very good, my dear Kevin Paul. Next, sin inverse x plus cos inverse x is equal to. Sin inverse x plus cos inverse x is equal to. Have you read? Sin inverse x plus cos inverse x is equal to. Very good, my dear Preetika. Yes, tell me. Very good, pi by 2. Similarly, tan inverse x plus cot inverse x is equal to. Tan inverse x plus cot. Very good, my dear Joseph. Tell me.
Sir, pi by 2, sir.
Very good, my dear Joseph. Similarly, secant inverse x plus cosecant inverse x is equal to. Okay, my dear Kiran Raj, I will give you next chance to Grayson. Okay, my dear Grayson, don't worry.
Okay, sir.
Kiran Raj, tell me secant inverse x plus cosecant. Very good. All of you listen carefully, my dear children. These are very, very, very important. Without knowing these formulae. Very good. Kiran Raj, down your hand. Down your hand. Down your hand. Okay. Now come to the next formula. Tan inverse x plus tan inverse y is equal to tan inverse x plus tan inverse y is equal to okay, my dear Kiran Raj, tell me tan inverse x plus tan inverse y.
Sir, it's tan inverse of x plus y by 1 minus xy, sir.
Very good, very good. Are all of you telling the answers without seeing your classwork notes and textbook, my dear children? Or simply seeing
Yes,
the
sir.
note? Yes, without seeing your classwork notes or textbook, without seeing only, tell me. Otherwise, at least listen. At least listen. Okay. Now tan inverse x minus tan inverse y is equal to tan inverse x. Very good. Grayson, tell me.
So tan inverse of x minus y by 1 plus xy, sir.
That's all. Very good. No need to remember that conditions. Okay. Up to CBSE level, no need to consider that conditions. Xy less than xy greater than 1, xy less than minus 1. That conditions will apply. Okay. Next one, 2 tan inverse x. There are three formulae. There are three formulae for 2 tan inverse x. Tell me, my dear Grayson, all of you listen carefully. Grayson is telling. Tell me, Grayson.
So sine inverse of 2x by 1 plus x square.
Very good.
Cos inverse of 1 minus x square by 1 plus x square.
Very good.
And tan inverse of 2x by 1 minus x square.
Very good. So we can write the value of tan inverse x in terms of sine inverse, in terms of cos inverse, and in terms of tan inverse. According to the context, according to the question, we can use that formula. Okay, my dear children. So memorize these formula well. That is why I spent for these 5 minutes. At least you will listen the formula. At least you will learn the formula. And one more thing, whenever you are doing sums related to inverse trigonometric functions, immediately you should write these equations like this. Just I will write here sine inverse of x. Suppose sine inverse of x is equal to theta.
Sir, your note is not visible, sir.
What, my dear Kiran Raj?
Sir, your note is not visible.
I will show you. I will show you. I will show you. Sine inverse
Yes, sir.
of minus x is equal to theta. Sine inverse of minus x is equal to theta. Whenever you are writing this equation, immediately you should remember sine theta is equal to x. This is an equation in inverse trigonometric functions. Immediately you should write an equation in trigonometric function like this. Okay, my children. Throughout the chapter, when we are using this equation sine inverse of x is equal to theta, immediately you should write this result. Similarly, cos inverse of x is equal to theta by implies what should we write? What should we write here? Cos inverse of my x is equal to theta. Immediately we should write cos theta
equals x, sir.
like this. Tan inverse of x is equal to theta. By implies, immediately you should write what is the equation?
So tan theta equals x.
Tan theta is equal to x. Same rule is applied for the remaining three, for cosecant inverse, for cot inverse, for secant inverse also. Okay, my dear children, will you remember these equations? Whenever you are doing sums related to inverse trigonometric functions, and when you are assuming this equation, sine inverse of x is equal to theta, immediately you should write this one. Keep the by implies a symbol, and sine theta is equal to x. Similarly for the remaining inverse trigonometric functions. Okay, my dear children, because we use these results according to the requirement. In solving the sums, we use this result or this result according to the requirement. Okay, my dear children, understood this point?
Okay, sir.
Please remember these 6. I wrote here only 3. Shall I write the remaining 3 also? Okay, I will write here. Cot inverse of x is equal to theta. By implies, what should we write? What should the equation we write? Cot inverse x is equal to theta. Cot inverse x is equal to theta. Tell me, my dear Kevin Paul, what should we write this equation here? Cot inverse x is equal to theta. By implies, what is the equation should be written here? Kevin Paul?
Cot theta.
Cot theta is equal to x. Cot theta is equal to x. Not only cot theta, my dear Kevin Paul. Not only cot theta. Cot theta is equal to x. You should remember the entire equation, LHS as well as RHS. Similarly, secant inverse x is equal to theta. By implies, immediately which equation should be written? Can you tell me, my dear Joseph? Can you tell me, my dear Joseph?
Sir, x equal to secant theta. Sec
Sorry,
theta. Sir.
tell me.
Sir, x equal to sec theta. Sir.
Very good. X is equal to sec theta or sec theta is equal to x. Both mean the same. Both gives a same meaning. And finally, cosecant inverse x is equal to theta. By implies, what is the equation should be written here? Can you tell me, my dear Blessina? Just wait, my dear Grison. Can you tell me,
Okay,
my dear
sir.
Blessina? If you assume this equation, if you assume
Cosec theta, sir.
cosec theta, that's all. That's
Sir,
all.
x is equal to cosec theta, sir.
Yes. Previously, I told you. You should remember LHS as well as RHS. So x is equal to cosec theta. Whenever you are assuming this part, immediately you should use this result. Suppose if you write this equation, immediately you should write this equation. That is why we have kept here by implies. By implies means if you write this equation, if you assume this equation, immediately you should write this equation. On the other hand, if you assume this equation, we can use this equation immediately. Got this point, my dear children?
Yes, sir.
Please remember this point. Now come to the question number 3. All of you open the textbook. Page number 47. Page number 47. Question number 3. In the last class, we have completed 2 questions so far in this exercise. Yes or no?
மேம் பாலஸ்ல என்ன நடந்துச்சுன்னு கண்டுபிடிக்கணும் மேம் பழைய காலம்
Prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. Okay, my dear children, see this question. What happened, my dear Grison? Grison?
Yes, sir.
What happened?
Nothing, sir.
Okay. See this question, my dear children. Prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. We have to prove this statement. Understood this question, my dear children? Understood this
Yes,
one?
sir.
We have to prove this statement. So, to prove this statement, let us take LHS. What is LHS? Can you tell me, my dear Jerome Jesli Raj? What is LHS of this statement? What is LHS of this statement?
So tan inverse
Tan
2 by
inverse
11
2 by 11
plus tan inverse 7 by 24.
7 by 24. This is the LHS of the given statement. If you observe this part, there are two terms. If you observe these two terms, these are in the form of which formula can be used here to simplify these two terms? Which formula is apt? Which
So
formula?
tan inverse x plus tan inverse y, sir.
Very good. Very good. Tan inverse x plus tan inverse y. These two terms are in the form of tan inverse x plus tan inverse y, where x is equal to 2 by 11 and y is equal to 7 by 24. Okay, my children. So, we use that formula to simplify these two terms. We use tan inverse x plus tan inverse y is equal to tan inverse of x means 2 by 11 plus y 7 by 24 by 1 minus 2 by 11, 1 minus xy. Yes or no? 7 by 24. Because here I am writing the reason why we wrote this step. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. By using this formula, by using this properties of inverse trigonometric functions, we wrote this step. Understood this step, my dear children? Jiram Jesli Raj, Ayush Singh, Yashwant Ram, Blessina, Krupal.
Yes, sir.
Understood this one? Why we have written this step? Now simplify the two numbers in the numerator. What are the numbers in the numerator? 2 by 11 plus 7 by 24. Yes or no? In the numerator, listen carefully and observe these two terms, my dear children. In the numerator, 2 by 11 plus 7 by 24. We have to simplify these two numbers. How do you simplify? By taking
LCM, sir.
yes, LCM of
LCM, sir.
yes, LCM of the denominators. For these two numbers, LCM of the denominators, 24 11 11 4s 44, 11 2s 22, 264 is LCM. 264 is LCM of these two numbers. Okay, then what will you get in the numerator? We wrote denominator, LCM of these two denominators. We wrote denominator 264. This is nothing but LCM of these two denominators. Then what about numerator? What about numerator? How do you write numerator? Can you tell me, anybody? What will you get? Can you tell me, anyone? Do you
So
know how
48
to?
plus 48 plus
Yes. 11. How many times? 24 times. 11 table. Remember these steps, my children. 11 table in 264. How many times it goes? 24 times. Into what is the numerator? We write that number as it is. We wrote that numerator as it is. Okay. Now keep that plus sign. If there is minus sign, we keep here minus sign. If there is plus sign, we keep here plus sign. Next, we take this denominator. 24 table. Assume 24 table is there. We have to divide this LCM by 24. We have to divide this LCM by 24. How many times it goes? How many times 24 table goes in 264?
11, sir.
11 times. Yes or no? Keep into symbol. 11 times into whatever is the numerator, we write it as it is. We write it as it is. Understood these two terms in the numerator? My dear Jerome Jasriraj, Ayush Singh, Yashwant Ram, Blessina, Krupal, Kiran Raj, Stains, Jensen, Powerson, Churchill.
Yes, sir.
Actually, this is a 6th, 7th standard question. Simplifying two fractions, addition of two fractions. No need to explain this much lengthy. Already you have learnt in 6th class and 4th, from 4th class onwards, you have studied addition of two fractions. Okay, whole divided by, in the denominator, LCM, we take LCM here, 1 is there, we can write it as 1 by 1. For our convenience, we can write 1 by 1. Here also we get 264 LCM. 264 is LCM because 11 into 24, 264. For 1 and 264, we get 264 only. Okay, then what will you get in the numerator? 1 into 264 minus, here we get 264. Yes or no? 11 into 24, 264 1 times. 1 into here, 2 sevens are 14. Understood this denominator part, my dear children? Understood this one?
Yes, sir.
Yes. That is equal to, in the numerator, what will you get here? In the numerator, 240, 24 2 times 48. 48 plus 14, 77. 48 plus 77 by 264 whole divided by 264 minus 14, 264 whole divided by 264. Just I am simplifying that fractions. Okay, my children. Now here 264 gets cancelled. Denominators. What will you get? Tan inverse of 48 plus 77. What will you get here? 15. 125 by, what will you get in the denominator? 250. 264 minus 14. Now let us simplify. Let us write this fraction in its simplest form. 125 1 times, 125 2 times. Yes or no?
Yes, sir.
Then finally what will you get here? Tan inverse of 1 by 2. If you observe RHS of the given statement, tan inverse of 1 by 2. Yes or no? We have to prove this one. Tan inverse of 1 by 2. This is nothing but RHS. We have taken LHS and we got RHS. Therefore, LHS is equal to RHS. Hence proved. Okay, my children. Understood this one?
Yes, sir.
Now come to the next question, fourth question. Question number 4. See the question number 4. Prove that, this also same as the third question. Prove that 2 tan inverse 1 by 2, 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. Understood this question, my dear children? Here also a statement was given. We have to prove the statement. We have to prove that statement. Here also we take LHS of the given statement. What is the LHS? What is LHS of the given statement? Can you tell me, my dear Powerson Churchill? My dear Powerson Churchill, what is the LCM? LHS of this given statement?
Sir, 2 tan inverse 1 by plus 2 tan inverse 1 by 7.
Very good. 2 tan inverse 1 by 2 plus tan inverse 1 by 7. If you observe this first term, which formula can be used for the first term? Have you identified any formula which is suitable to write this first term? Very good, my dear Pritika. 2 tan inverse x. If you observe this first term, it is in the form of 2 tan inverse x, where x is equal to 1 by 2. So first of all, we should write the formula for 2 tan inverse x. Okay. What is the formula for 2 tan inverse x? Can you tell me, my dear Staines Johnson? What is the formula for 2 tan inverse x? Staines Johnson, are you there online? Staines Johnson.
Yes, sir.
Can you tell me what is the formula for 2 tan inverse x?
Tan inverse 2x by 1 minus x square.
Very good. We should use that formula only because the second term is tan inverse. So we should write 2 tan inverse x formula, tan inverse of 2x by 1 minus x square. Okay. Tan inverse of 2x by 2 into, what is x here? 1 by 2. Okay, my children. By 1 minus x square, 1 by 2 whole square. We write the second term as it is. Here, I applied the formula, 2 tan inverse x formula. What is the 2 tan inverse x formula? Tan inverse of 2x by 1 minus x square. I will write that formula here because by using this formula, we wrote the first term. Now, tell me the first term after simplification. What will you get? Here 2 gets cancelled in the numerator. 2 gets cancelled. In the numerator we get only 1 by 1 minus here 1 by 2 whole square. What is the value of 1 by 2 whole square? What is the value of 1 by 2
1
whole
by
square?
4, sir.
1 by 4. Very good. Plus we write the second term as it is, tan inverse of 1 by 7. Understood this step, my dear children?
Yes, sir.
Yes. Only Grayson is responding. What about others?
Yes, sir.
Just like audience, you are watching the screen without any response. In a cinema theater, just like audience, they will not respond to anything. Just watching the movie, that's all, and go to the home, that's all. They will not respond to anything. Tan inverse of, tell me what will you get here? 1 by
3
1
by
minus
4,
1 by
sir.
4. What will you get?
3 by 4, sir.
3 by 4. 3 by 4 plus tan inverse 1 by 7. Tan inverse of 1 by 3 by 4. Can you tell me, my dear Janani? What is the value of 1 by 3 by 4? How do you write? How do you simplify?
So into move your notebook also. Yes.
You know, is it okay?
Yes, sir.
Tell me 1 by 3 by 4, my dear Janani. How do you write this fraction? 1 by 3 by 4.
So 4 by 3.
Yes, very good. 4 by 3. Tan inverse of 4 by 3 plus tan inverse 1 by 7. Now come to this step. If you observe these two terms in this stage, in this step, if you observe the two terms, these are in the form of tan inverse x plus tan inverse y. Yes or no? So in this stage, we have to use tan inverse x plus tan inverse y formula. That is equal to, what is x value here? Tell me, Krupal, what is x here? What is x here? Krupal,
Yes, sir.
what is x? What is the value of x here? Just I compared this statement, I compared this step with tan inverse x plus tan inverse y. I compared these two terms with tan inverse x plus tan inverse y. Then what is the value of x here?
Sir, tan inverse 4 by 3.
I am asking what is the value of x? What is the value of x here? Yes, my dear Kirandas.
Sir,
Tell
it's
me.
4 by 3, sir.
Yes, very good. 4 by 3 only. Not
X is 4 by 3 and
tan
y is
inverse 4
1 by
by
7.
3. X value is 4 by 3 and y value is 1 by 7. Very good, my dear Kirandas. X value is 4 by 3. Okay, my dear Krupal. Listen the question carefully, understand it well and respond. Okay. I told here these two terms are compared with tan inverse x plus tan inverse y. Then what is the value of x? So x value is 4 by 3 and y value is 1 by 7. Understood, my dear Krupal?
Sir.
Yes. So we use that formula tan inverse x plus tan inverse y. Previously Grayson said, do you remember what is the formula for tan inverse x plus tan inverse y? Can you tell me, Krupal? What is the formula for tan inverse x plus tan inverse y? Krupal, are you listening or not?
Yes, sir.
Tell me. Tan inverse x plus tan inverse y is equal to. Just wait, my dear Kiran Raj. Just wait for a moment. Let him recollect that knowledge. What is the formula for tan inverse x plus tan inverse y? Yashwantram, can you tell me? Yashwantram, are you there online? Yashwantram,
Yes, sir. Yes, sir.
tell me the formula for tan inverse x plus tan inverse y.
Sir, sir,
Tan inverse x plus tan inverse y is equal to. Tell me the formula.
Sir, Ganesh.
uh,
Do you know it or
sir, is
not?
it,
Tell.
sir, tan inverse x plus y by 1 plus xy?
1 minus, not 1 plus xy. 1 minus xy. Okay.
Okay,
So
sir.
in that formula, we are substituting x and y values, where x is equal to 4 by 3 and y is equal to 4 by 1 by 7. So x plus y by 1 minus xy, that is 4 by 3 into 1 by 7. Because tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. By using this formula, we wrote this step. By using this formula, by applying this formula, we wrote this step. Okay, my children. Now, tan inverse of, now can you simplify these numbers and tell me the answer? Do that part, my dear children. Do it yourself. Do this simplification part by yourself, my dear children, and tell me the answer.
Sir, it will be tan inverse of 31 by 21 by 17 by 21, sir.
31 by 21.
By 17 by 21, sir.
17 by 21.
And then
So
it will be
here,
tan.
21 gets cancelled. 21 gets cancelled. Finally, what will you get here? Tan inverse of 31 by.
31 by 17, sir.
If you observe the given statement, this is nothing but RHS. Yes or no? This is RHS. Okay. Hence proved. Understood, my children? We got
Yes,
here.
sir.
We got here tan inverse of 31 by 21 whole divided by 17 by 31. Here 21 gets cancelled, denominators gets cancelled, and finally we get tan inverse of 31 by 17, which is nothing but RHS of the given statement. So the given statement is proved. Understood, my children?
Yes, sir.
Right. Now come to the next question. Come to the next question. What is the next question? Question number 5. Tell me the question number 5.
Yes, sir. So tan inverse of root of 1 plus x square minus 1 by x, sir.
Before that, some statement is given at the beginning of the question, right? Tan inverse of root of 1 plus x square, square root of 1 plus x square minus 1 whole divided by x, comma x is not equal to 0 in the simplest form. This is the actual question in the simplest form. Okay, my children, this is very important model. This is very important model. A function in the inverse trigonometric function will be given. We have to write that given inverse trigonometric function in its simplest form. Okay, by using substitution method. What happened, my dear Yashwantaram? What happened?
Sir,
What happened? Your mic is on
sir,
now.
nothing happened. Sorry,
Now,
sir.
in the given inverse trigonometric function, here we have to substitute a suitable trigonometric function. Means x is equal to sine theta. Okay. See these statements, my dear children. In this given inverse trigonometric functions, we have to substitute either x is equal to sine theta x is equal to or cos theta, either x is equal to tan theta, x is equal to cot theta, x is equal to secant theta, or x is equal to cosecant theta, so that we should get a trigonometric identity. We should get a trigonometric identity when you are substituting any one of these 6 substitutions. Only one is suitable to get an trigonometric identity. Suppose, please listen this question carefully, my dear children. Suppose in the place of x, if you write here, what will you get here? If you substitute x is equal to sine theta, under the square root, what will you get? Tell me.
Sir, 1 plus sine square theta.
1 plus sine square theta. Is it a trigonometric identity? Is it a trigonometric identity 1 plus sine square theta? It is not a trigonometric identity. Suppose if you substitute x is equal to cos theta, what will you get? What will you get
1
here?
plus cos square theta, sir.
1 plus cos square theta. There is no trigonometric identity. 1 plus cos square theta is equal to some answer, some trigonometric identity we should get. So in that case also, we are not getting trigonometric identity. Suppose if you substitute x is equal to tan theta, tell me, what will you get here?
1 plus tan square theta, sir.
Is it a trigonometric identity? 1 plus tan square theta is equal to, do you remember that? Trigonometric identity is there. 1 plus tan square theta is equal to
Cot square theta, sir.
sec square theta. 1 plus tan square theta is equal to sec square theta, secant square theta. Okay.
Okay, sir.
1 plus tan square theta is equal to secant square theta. So in this case, we are getting a trigonometric identity. Yes or no? Like this, you have to cross check. You have to cross check which trigonometric function is suitable for the substitution, so that you should get trigonometric identity. Okay. So in this case, understood this point, my dear children? Is this point clear? We have to substitute any one of these 6 trigonometric functions in the given inverse trigonometric function, so that you should get a trigonometric identity. In the first two cases, we are not getting a trigonometric identity, but in the third case, just to assume that these are 6 cases. For sin theta is first case, cos theta is the second case, tan theta is third case, cot theta is fourth case, secant theta is the fifth case, and cosecant theta is the sixth case. So in the third case, we are getting a trigonometric identity. 1 plus tan square theta is equal to secant square theta. So here, this is a suitable substitution. So put tan x is equal to tan theta. Put x is equal to tan theta. Understood this point, my dear children? Why we have selected x is equal to tan theta?
Yes, sir.
Why we have selected x is equal to tan theta? Tell me the reason. Why we have selected x is equal to tan theta?
Sir, if we substitute in the value of x, we get a identity, sir.
Yes, trigonometric identity. That is the reason. So x is equal to tan theta. Immediately I told you, what should we write? If you assume x is equal to tan theta, then what is theta value? Then theta is equal to
Tan inverse of x.
tan inverse of x. Previously I told you, if we assume x is equal to tan theta, then immediately you should write this equation also. Okay, my children. Now let us take this given inverse trigonometric function. Tan inverse of root 1 plus x square minus 1 by x is equal to tan inverse of root of, we are substituting x is equal to tan theta, yes or no? Minus 1 by tan theta. By substituting x is equal to tan theta in this given function, we get to this step. Understood this step, my dear? Kevin, Paul, Janani? We kept here, we substituted x is equal to tan theta in the given inverse trigonometric function. Then we got this step. Then tell me here, tan inverse of under square root, what will you get here? 1 plus tan square theta. What is the value of 1 plus tan square theta? What is the value of 1 plus tan square theta? Previously I told you.
So secant square theta.
Yes, secant square theta. Secant square theta minus 1 by tan theta. Because 1 plus tan square theta is equal to secant square theta. By using this trigonometric identity, we wrote this value. Okay, my dear children, understood this one?
Yes, sir.
Now, come to this next step. Tan inverse of, that is equal to tan inverse of square root of secant square theta. What will you get here? Secant theta. Yes or no? Square root and square. Square root and square gets cancelled. Square root and square gets cancelled. We get only secant theta minus 1 by tan theta. Understood this part?
Yes, sir.
Okay. Now, we simplify. Secant theta can be written as 1 by cos theta. Tan theta can be written as sin theta by cos theta. Yes or no? So,
Yes, sir.
tan inverse of 1 by cos theta minus 1 by sin theta by cos theta. Because secant theta is equal to 1 by cos theta and tan theta is equal to sin theta by cos theta. By using these results, I wrote this step. Okay. Now let us simplify here. What will you get? 1 minus cos theta by cos theta. By taking LCM, we get 1 minus cos theta by cos theta by sin theta by
Sir,
cos
you need
theta.
move that notebook, sir.
Tan inverse of 1 minus cos theta by cos theta by sin theta by cos theta. By taking LCM and by simplifying, we get in the numerator 1 minus cos theta by cos theta. By denominator, I wrote it as it is. I wrote it as it is. Okay. Tan inverse of here, denominators gets cancelled, cos theta, cos theta. Finally, we get 1 minus cos theta, 1 minus cos theta by sin theta. 1 minus cos theta by sin theta. Okay, my children. By simplifying these terms, finally we got to tan inverse of 1 minus cos theta by sin theta. Okay. 2 more steps are left for this question. Only 2 more steps. That is equal to 1 minus cos theta. 1 minus cos theta can be written as 2 1 minus cos theta 2 sin square theta by 2. These are half angle formula. Similarly, sin theta can be written as 2 sin theta by 2 into cos theta by 2. Because Okay, my children. By using these two formulae, we wrote numerator and denominator. Okay. So here 2 gets cancelled, and finally we get tan inverse of here 1 sin theta by 2, here 1 sin theta by 2 gets cancelled. Finally we get in the numerator sin theta by 2 by cos theta by 2. Understood this step, my children? Finally, tan inverse of, how can we write sin theta by 2 by cos theta by 2? Tan theta by 2. Yes or no? Sin theta by 2 by cos theta by 2. Tan theta by 2. Here tan inverse tan gets cancelled. Finally, we get theta by 2. Theta by 2. That is equal to 1 by 2 into theta. Theta by 2 can be written as 1 by 2 into theta. So 1 by 2 into, here theta value. What is theta here at the beginning? Theta is equal to tan inverse x. Theta is equal to tan inverse x. So 1 by 2 tan inverse x. So this is a simplest form of the given inverse trigonometric function. Okay, my children? Now the time is 10 past 52 minutes. Again, watch this video one more time, my dear children, to understand this question well. Okay. Now the time is 10 past 53. You can leave the meeting, my dear children. Take rest. Take care of your health, my dear children.
Thank you, sir.
Stay at home.
Thank you, sir.
Stay
Thank
safe.
you, sir.
Thank you all. Use mask. Sanitize your hands frequently and maintain social distance, my dear children. Thank you all. All of you watch this video again and again. Thank you, my dear children. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, Grayson. Thank you, Joseph. Thank you.